Okay, so unfortunately, I haven't marked the tests yet. I'll try to do that as quick as I can. Had a bit of a busy weekend. What else? So we're going to start on chapter 2, which is ratios and proportions. So I think we'll just start with basic order of operations. It's not really the first lesson. It's kind of just an independent lesson. It just goes wherever. So I figured we'd do that today. So, hold on, let me just finish taking the initial attendance. So we got lots of people, that person, that person, that person, and lots of people. Okay, I think I got mostly everyone. Oh, this person too. Okay. Oh, and he's still good. He's still in there. He's not trying to escape. Good. Okay. Let's start. Share screen. Let's go to this. Okay, so this is chapter 2, ratios and proportions, and this is basic order of operations. I figured it would be something a little bit easy to start the week off with. So let's start. So in this lesson, we learn how to simplify arithmetic expressions using the basic order of operations. So basically, at one point, they had to come up with a particular order for evaluating numerical expressions. So for example, let's say you have an expression with a bunch of numbers and you have plus signs, you have minus signs, you have division symbols, and you have to figure out which operation do you do first, because it does make a difference. If you do the operation in different orders, you'll actually get different numbers, which is not really permissible in math, at least not at such a kind of fundamental arithmetic level. So what we're going to do is something that you probably remember from high school, which is BEDMAS, which is a way to remember which operation to do first when you're evaluating an expression. So let's just do an example to start off, just to prove that the order that you do these problems in, it does make a difference. So here is a pretty simple example. So let's say we have the expression 6 plus 10 divided by 2. And we're trying to figure out, should we do the plus part first, the 6 plus 10 part, or should we do the division part? So let's do it both ways, just to prove that, yes, you would get a different answer. And therefore, you do need a systematic way of doing these. Okay, so what do we do first? First, we do the plus part. Now let's see what answer we get. So let's do this part right here. 6 plus 10 is, here, I'll write it over here. 6 plus 10 is 16 divided by 2 is equal to 8. So that's what you would get if you did the plus part of the expression first. On the other hand, if you did the division part of the expression first, you would indeed get a different answer. So here's our expression, 6 plus 10 divided by 2. And let's do this part first. So then you would get 6 plus 5 equals 11. And in the previous case, we got 8. So yes, in this case, whether you do the addition or division first, it makes a difference, and the answer does depend on it. So I guess at one point in history, a bunch of mathematicians got together and decided what is the proper order of operations that we use. So that is this right here. And an easy way of remembering it is BEDMAS. So first you start with the brackets or the parentheses. You always start with the innermost brackets, and then you work your way outward. And then you go next to exponents, and then you do multiplication and division. Now between multiplication and division, the order makes no difference. So you just do it from left to right. And then the last thing you do is addition and subtraction. So again, between addition and subtraction, the order is irrelevant. So you just do it from left to right. And yeah, so that, if you kind of put it all together, is BEDMAS: brackets, exponents, division, multiplication, addition, and subtraction. So it's a good mnemonic device for remembering the order of operations. It's one of the few things people seem to remember from high school. They remember y equals mx plus b, they remember BEDMAS, and I think that's about it. Okay, so let's do an exhaustive number of examples, and we'll go through lots of different types. We'll start with the easiest ones. Okay, so this one, 9 minus, actually, hold on, maybe I should do, because we haven't covered any exponents yet. Okay, I'll do that when we reach it. Okay, so this one's fairly simple. In brackets, you have 9 minus 4, and then that's multiplied by 2. So you just go through BEDMAS. Of course, in this case, you start with your brackets. So 9 minus 4 is equal to 5, and then you multiply that by 2, and you get 10. So that one is not too bad. Of course, we'll start with the easiest ones, and then we'll get to some more difficult ones. And then there's a couple that are kind of just for fun. Okay, next one is 10 minus 6 times 3. So BEDMAS tells us to do the multiplication part first before we do any of the addition or subtraction parts. So let's do that. Let's see. So this is 10 minus, and you got 18 for the part on the right, and 10 minus 18 is minus 8. Good, good. And then the next one you have 18 divided by 6 plus 3 times 2. Okay, so for this you could do the division part and you could do the multiplication part kind of at the same time, just so you don't have to keep rewriting the expression. So 18 divided by 6 is 3 plus, and then 3 times 2 is 6. And 3 plus 6 equals 9. So that's kind of the basics of how order of operations works.
I have a question.
Sure.
So with the second one, my brain obviously went to do 18 minus 10, but you need to do the 10 minus 18.
Yes, yeah, exactly, because the 10 is presented first.
Gotcha.
If it was reversed, then you would do it that way.
Okay, I just want to make sure that was how you did it. Thank you.
Let's see, what else do we have? And then of course the solutions are provided in case anyone wants to use the PowerPoint for practice. Let's do a few more. Okay, for this one we have 13 plus 5 divided by 6 minus 3. Actually, these always kind of amuse me because every once in a while you see these on Facebook where it's like a very, very simple expression, and then it's like 5 pages of people trying to figure it out. And it always makes me laugh how long the discussions go on about what the correct answer is. Yeah, so anyways, for this one, let's do brackets first. 13 plus 5 is 18. And then I'll write the rest of it just to see what we have. So now we have 18 divided by 6 minus 3. So do the division part first. 18 divided by 6 is 3. And then you got 3 minus 3. So you get 0 for that part right there. Okay, what else do we have? I don't want to get too repetitive with these because these ones are pretty similar. Anything more? Let's see. Okay, I'll do this one right here. I'll leave the other one just for practice because it's nearly the same. Okay, so for this one, 18 divided by, and then we have something in brackets, and then at the end we have times 2. So BEDMAS brackets are first. So you do 18. There's so many 18s in these questions. I didn't realize that. 18 divided by 9, that's what you got in your brackets, times 2. And then in this case, we're just left with division and multiplication. And like I mentioned before, the order is irrelevant, so they decided just do it from left to right. So just do the 18 divided by 9 part first, which is 2. And then you do 2 times 2, and you get 4. Good, good. The last one, because it's so similar, again, I'll just leave it for practice. Okay, let's go to some other slightly different ones. This one's interesting. So we have 8 times stuff in brackets minus 4 times some stuff in brackets. So again, let's do the brackets first. We'll just do both of them so we don't have to keep rewriting these. So this will be 8 times 5 minus 4 times 7. And notice in this case, I use a notation for multiplication that's a little bit different from what you typically see. I don't like using multiplication signs. In general, mathematicians don't use them. So I just use dots like this. So if you ever see a dot between two numbers where it's in the middle of the number, or in the middle between the two numbers, it just denotes multiplication. Yeah, the multiplication sign is not a good piece of notation because it looks like the letter X, and X is most commonly used in algebraic expressions. So mathematicians have kind of left behind the multiplication sign. Or in this case, if you wanted to, you could just keep brackets around them. In this case, it's more just notation. It doesn't really matter. It won't affect the answer for this one. And then you do the multiplication parts first. So let's do 8 times 5, which is 40. Yes, 40, yes. 40 minus 4 times 7 is 28. And 40 minus 28 is 12. The next one is different. Actually, for the next one, I'm just gonna scratch this part out because I don't like presenting it like that. So the next one is 12 minus 4 over 6 minus 2. So for this one, it's a little bit different. What you do is you just evaluate the top, and then you evaluate the bottom, and then at the end, you just do top number divided by bottom number. So when it's actually written as a fraction, you I guess it's kind of an exception to BEDMAS in the sense that you're doing the final division at the very end, no matter what. So in this case, you just do, so 8 is on top. On the bottom, you get 4. And then 8 divided by 4 gives you 2. So that's what you do for those. What else do we have? Oh, now before we continue, let's do a bit of a intro on exponents. So let's go to a whiteboard. Okay, so exponents are a way of denoting repeated multiplication. So let's just start off with some examples, and the pattern becomes pretty clear pretty quickly. So let's say you have 2 raised to the 2. What that gives you is 2 times 2, which is 4. And you could have 2 raised to the 3, which would be 2 times 2 times 2, which is 8. And then you could keep going like that. So 2 raised to the 4 is 2 times 2 times 2 times 2, which is 16, et cetera, et cetera. So a number raised to an exponent is that number multiplied by itself that many times as the exponent specifies for you. So keep in mind, like, for example, if you have 2 to the 6, a lot of people think that that's just the same as 2 times 6, and it's not the same. Otherwise, we would have just written 2 times 6. So everyone keep in mind, it's repeated multiplication where you're taking the base number and multiplying it by itself. So the proper way to figure out 2 to the 6 would be 2 times 2 times 2 times 2 times 2 times 2 equals something. What does that equal? 64. 2, 4, 8, 16, 32. Yeah, 64. In that case, I would definitely just use a calculator. There's a button on your calculator. It looks like a little hat like this, and that's the exponent button. So if you did want to put in 2 to the 6, you would type in 2, you would type in the little hat, you would type in 6, and it would give you the direct answer. So that is exponents. Basically, at one point, people got tired of writing repeated multiplication, especially when you have giant expressions. So they just invented exponents, which are a shortcut way of denoting repeated multiplication. Let's do one more example. If you have 10 raised to exponents, it ends up being very convenient because our number system is based on 10. So 10 to the 2 is 10 times 10, which is 100. 10 to the 3 is 10 times 10 times 10, which is 1,000. And then of course, 10 to the 4 is 10,000. So with 10, exponents are really easy because you just put 1 with the appropriate number of zeros according to what the exponent is. So like 10 raised to the 4, I just write a 1, and then I just put 4 zeros. And so it's very convenient when it comes to 10. You can't really use that trick with any other numbers. You would just have to work it out with a calculator or work it out on paper. But with 10, it's always very convenient. And what else? every number that doesn't have an exponent, like if you just have a plain old 10, it technically has an exponent of 1, but you just never bother to write it because it's kind of just automatic. So I think that's all we need for exponents at this point. Let's go back to the PowerPoint. Let's see, yes, let's clear this. Oh yeah, this one has a really bad eraser. Darn it. Okay, I'm just gonna switch to a whiteboard. Okay, new share, whiteboard. Let's get rid of this. Okay, the next one is 128 divided by 2 times 4 in brackets. And then the brackets are raised to an exponent of 2, and then you subtract 3. So this one is a little more complicated than the other ones, but let's just take it step by step. So BEDMAS, brackets. So let's do the brackets. 2 times 4 is 8. So far, so good. So 128 divided by 8. And the exponent still stays there because we haven't dealt with that. I'll just put it raised to the 8 minus 3. And then you just go through BEDMAS again and reevaluate. So brackets, no more brackets. Exponents, okay, we got to do the exponent. So 8 raised to the 2 is 8 times 8. So it's 64. Again, remember, it's the number times itself. So that's 128 divided by 64 minus 3. And now BEDMAS division, and then we do the subtraction. So 128 divided by 64 is 2. And then 2 minus 3 gives you minus 1. So that one wasn't too bad, but of course you do have to know the definition of exponents in order to solve that one. And then we have another one that kind of looks the same, but it is different. This one is 128 divided by, in brackets, 2 times 4 squared minus 3. So this, again, it looks almost like the same thing, but it is different because in the previous one, the 2 was applied to everything inside the brackets. In this case, it's a bit different. The 2 is only physically attached to the 4, so it only applies to the 4 for this one. It doesn't apply to what's overall in the brackets. So you do have to look closely at a lot of these. So let's start BEDMAS, brackets. Okay, and now within the brackets, you kind of have to reevaluate BEDMAS because you have an expression within the brackets in this case. So of course you do the exponent part first. So let's do that. 128 divided by, in brackets, 2 times, so 4 times itself is 16, minus 3. And now let's do the brackets again. So 128 divided by 32 minus 3. And again, you do division, and then you do subtraction, and then we're good to go. So 128 divided by 32 is 4. And then 4 minus 3 is equal to 1. Good, good. Does anyone have any questions thus far? Okay, everyone seems pretty good. Let's do a couple of larger ones, mostly just kind of for fun and just to see, yeah, what else we can figure out about BEDMAS. Let's get rid of this. So this one is 3, and then you have a square bracket, very fancy. And then you have a round bracket inside, and in that you have 2 plus 4 times 2 squared. Sorry, my writing is not great here. Let me just clarify these signs. Okay, 2 plus, let's try to write a plus sign, plus, very good. Multiplication, good, good. And then you end that bracket, and then minus 6 times another bracket in there is 3 minus 1. then you end the round bracket, then you end the original square bracket. So in this case, you could kind of note that it's 3 times basically everything, because everything is encapsulated in brackets. So for this question, I would just leave the 3 at the front and just figure out whatever is inside the square brackets. And then at the end, I would just do 3 times whatever that number is. So the 3 kind of just sits there until the very end. So let's figure out, plus in BEDMAS, it does specify to do the inner brackets first. So let's do that. So let's start with, so there's 2 inner brackets. It doesn't really matter which one we start with. So let's start with the left one. So 3 square bracket, round bracket. Okay, so within this bracket, there's plus, there's multiplication, there's an exponent. So let's definitely do the exponent first. So 2 plus 4 times, so 2 to the 2 is 4. End bracket minus 6 times. Now let's do this bracket. 3 minus 1, of course, is 2. And at this point, you could put brackets around the 2, which I have, or you could just put a multiplication sign between them. Once it's just a number sitting in the brackets, it doesn't really matter what notation you use. Okay, so let's keep going with the brackets. 2 plus 4 times 4, so that's 2 plus 16. 2 plus 16. Minus, and now 6 times 2 is 12. And now you end the square bracket. Good, good, good. And then you just keep going. Actually, at this point, if you look at the inner expression, the brackets are no longer relevant because there's only plus and minus inside the square brackets. So you would do it from left to right regardless. So the brackets around the 2 plus 16 part, they make no difference in this case because it's already taken care of. But regardless, let's just keep going. So 3 bracket, 2 plus 16 is 18. So we're almost done. We've almost figured out what's actually inside the square brackets. Okay, so that's 3 square bracket, 18 minus 12 is 6. So at the end, you get 3 times 6. Oh yeah, and if you ever have just a number sitting next to another number in brackets with no sign between them, it's always implied to be multiplication. So that is 18. Good, good. So that one, hopefully everyone didn't find that too bad. Again, I'd recommend maybe going through the PowerPoint and trying these ones without looking at the solution and see what answer you get and see where your mistakes are. Okay, there is another one. And then there's one more. For the next one, yeah, usually I would give a couple of exercises for everyone to try, but since we don't even have that much time anyways, so let's just keep going. So this one is even more complicated. Let's see, so this is square bracket 4 times round bracket. And in there you got 8 minus 6, and then raised to the whole bracket is a 2. And then you have a plus 4, and then you end your square bracket, and then you have even more. You got round bracket 3 minus 2 times 8. And then you have even more, you have stuff on the bottom. So this is, on the bottom you have 2 to the 2 times 2 to the 3 plus 5. So this one looks a bit intimidating, but again, just go through BEDMAS, see what you get. So brackets, let's do some brackets. So square bracket, that'll just stay the same because we always do the inner ones first. So in this case, we get 8 minus 6, which is 2. So, and then I'll just keep the exponent right there, plus 4, and your square bracket. Next bracket is 3 minus 2 times 8. So let's do the multiplication part in there. So that's 3 minus 16. And the round bracket. And now let's do some of the bottom numbers. Okay, so for the bottom, there's a couple of things we can do. 2 raised to the 2 is 4. bracket, and then within the brackets, 2 raised to the 3 is 8. So that's 8 plus 5 in the brackets. And then you just keep going and just kind of keep cycling through BEDMAS and keep simplifying it. For the top, we can simplify the exponent that is in there. So square bracket, 4 times, and that would be 4 times 4. So 4 times 4 plus 4. And the square bracket times, and then in the round bracket, you have 3 minus 16. So that's minus 13. Okay, and keep in mind that, again, if there's no sign between the brackets, it's always implied to be multiplication. So it's whatever is in the first square brackets times, in this case, minus 13. And then what else can we do? 4 can just stay on the bottom. And then 8 plus 5 is 13. So at this point, there is something you could do to simplify this. You could cancel out the 13 on the top and the 13 on the bottom. The negative sign on top in front of the 13 would still remain there because there's nothing to cancel out the negative sign. But I'm just going to keep going. I'm not going to bother doing cancellation because most people don't do it in this question. So just for the sake of consistency. Sorry. Okay, what else do we have? Okay, so let's do the square bracket. So 4 times 4 is 16 plus 4, and that bracket, and then the minus 13 can just sit there. And at the bottom, 4 times 13 is 52, I think. Yeah, 40 plus 12 is 52, yes. Okay, so we're almost done this one. Now let's do 16 plus 4 is 20. Times minus 13 over 52. Okay, so because I didn't do cancellation in this case, I'm going to need a calculator. 20 times negative 13 is minus 260. So that's minus 260 divided by 52. And we get minus 5 for the answer. So good, at least we get a nice round number for the answer. And yeah, if you had done cancellation, you would end up getting the exact same answer. It would just be a little bit quicker. Okay, so there is one left. And this one looks really, really nasty because it's all fractions, but it's not bad. And at least it combines everything that we've previously learned about fractions. So let's do this one. And then I guess we don't really have much else to do. Okay, get rid of this. So this one, again, don't be intimidated. 1 over 3 plus 2 over 3 divided by 3 over 4 times 1 over 2 squared. Ooh, this one looks tough. Okay, so BEDMAS. Brackets, exponents. So let's take care of the 1 over 2 squared part. So how the heck do we figure out 1 over 2 squared? Well, let's just do that off to the side because it's surprisingly straightforward. So let's do that over here. 1 over 2 squared. So a number squared is just the number times itself. So let's just do 1 over 2 times 1 over 2. 1 over 2 times 1 over 2. And then at this point, you just use standard fraction multiplication that we learned in chapter 1. Just multiply the top numbers, multiply the bottom numbers, and you get your answer for that part. So you get 1 over 4. So that part actually isn't too bad. So let's rewrite this and we'll replace the 1 over 2 squared with 1 over 4. So this is 1 over 3 plus 2 over 3 divided by 3 over 4 times 1 over 4. So that makes it look a little better. Okay, what to do next? We got plus, we got division, we got multiplication. We got to do the division and multiplication parts first from left to right. So let's do the division part first. So hopefully everyone remembers how to do division with fractions. So let me just put I'm just gonna put brackets around here just so everyone knows exactly what part we're talking about. So we're focusing on this part. So we do division the way we always do it. First fraction stays the same. So the 2/3 will stay the same, and then change it to multiplication, and then flip the other fraction so that it's now 4/3. So same way we always do it, and all the other numbers will just kind of hang out and stay the same. Plus bracket 2/3, change it to times, and flip the second fraction. And again, everything else is just gonna chill there and stay the same. Okay, now let's do the multiplication part. Again, for multiplication, it goes from left to right, so we'll just do what's in the brackets right here. So on top, we have 2 times 4, which is 8, and on the bottom, we'll have 3 times 3, which is 9. So 1/3 plus, and I guess we don't really need brackets anymore, so that will be 8/9 times 1/4. Okay, so hopefully I haven't made any mistakes yet. Oh yeah, there was also some cancellation that we could have done here, but again, just for the sake of, we do it in the PowerPoint. So if you want to see that version of it, go ahead. We could have hypothetically canceled out this 4 and this 4, but I'll just continue as we were for now. Okay, what next? We have plus, we have multiplication. So let's do the multiplication part right here. And I'm just putting brackets around just for kind of illustration. Okay, so 8 times 1 is, well, here, let's write the 1/3 part first, and then plus. 8 times 1 is 8. 9 times 4 is 36. Okay, good, we're almost done. So at this point, all we're doing is just adding 2 fractions, so not too bad. There's kind of 2 different ways of doing this. The 8/36 itself is reducible. So if you wanted to, you could reduce it first and then continue on with the question. But I mean, we're going to be finding a common denominator regardless. So I'm not sure if there's much point in reducing it. I think it would be an equal amount of work in either case. So let's just keep it like this, and let's just find a common denominator. And in this case, I guess it would just be, would it just be 36? Is 36 divisible by 3? Oh yeah, of course, yeah, it's 12, yeah. Okay, so 36 will be our least common denominator in this case, because you already have a 36 on the bottom for one of them, and 3 indeed divides into 36. So for the first fraction, let's multiply it. So 3 times 12 would get 36. So let's multiply 12 on the top and the bottom. So you get 12/36 plus 8/36, and that gives you 20/36, which does reduce. At the very least, you could take a 2 out of it because they're both even numbers. So yeah, what else could you, what's the maximum that you could take out of that? You could take a 4 out of the 20. I guess you can't really take that out of the 36. Let's just take a 2 out of it and see where it leaves us. So divide by 2, divide by 2, and you get 10/18. Oh, okay, and then yeah, you can keep going a little bit. You can take another 2 out of there. Divide by 2, divide by 2, and you get 5/9. So yeah, overall, sorry for doing it in 2 steps. Yeah, overall, you could have just taken a 4 out of it, but I think I'm just tired and I didn't see that. So your overall answer is 5/9. So with this one, there's various routes that you could take, but it's really just up to you on whether or not you want to like use cancellation at some point, or reduce something first and then find a common denominator, etc. But as long as you do everything properly, you'll get the same answer for everything. So that's all I have for BEDMAS. And I guess, yeah, it ends at 1:50 anyway, so I guess we're not really ending that early. Here, I'll let everyone see the snake again for a minute, just as I double check the attendance. Does anyone have any questions about BEDMAS? Oh, and I'll post the second assignment as well, but for now, there's no due date. We'll just decide on the due date once we finish chapter 2. So let's stop sharing. Let's put my video back on. Let's see if Shadow is still in that cupboard. Oh, no, he's not. Oh, crap. Okay. Shadow, where did you go? Okay. I may have lost my Python. No worries, he couldn't have gone far. It's not like there's bunny rabbits sitting across the room. Okay, everything's good. He's close by, he's somewhere. So he says goodbye at least. Here, I'll stop the video. Okay, I got to do the attendance as well. And as I'm doing this, just let me know if you have any questions. Let's see. Okay, pretty much everyone is here. Yeah, that's my own fault for putting him in a drawer. They can escape from literally anything. Let's see. We got not that person. One more to check for. And nope. Okay. And I'll write down. Yep. Okay, so I guess that's it for today. So I will virtually see everyone tomorrow. And yeah, have a great day. Thanks for coming.